So in this section, we're looking at a series of formulas called the double angle formulas. And the name should be pretty obvious as we start to look at these, because we're looking at the sine, cosine, and tangent of 2 theta. And we have this sine, cosine, or tangent of 2 theta in terms of, in each case, sine of theta, cosine of theta, or tangent of theta, or some variation combination of those. So meaning that if we know some information about the single angle, then we can find the trigonometric ratios of the double angle. So we'll notice that in the case of sine and tangent, there's just one formula that we have to work with and that we have to be familiar with. In the case of cosine of 2 theta, we can see that there are 3 different formulas. Now, we don't have to memorize all 3 of these. Really, it's the top one that is kind of the basis for the double angle formula for cosine. And the other 2 are just derived by using the Pythagorean identity that we studied at the very outset of our look at these various formulas and identities. And so if we take that cosine squared minus sine squared, and if we were to replace cosine squared with 1 minus sine squared theta, if we were to make that substitution going back to our Pythagorean identities, we'd have 1 minus sine squared minus sine squared, or 1 minus 2 sine squared, which would give us this second version of the identity. And by the same approach, if we were to replace sine squared with 1 minus cosine squared theta, well, if we distribute the negative, we're going to end up with cosine squared minus 1, but then minus a negative, so plus cosine squared. That's how we eventually end up at this other variation. So all 3 of these will lead us to the same answer. We can use any one of them interchangeably, but we typically list them all off just because we can. So let's take a look at an example of how we can use these double angle formulas. So in the given information, we're told that the sine of the single angle, the sine of x, is 3/5. And a key element of the information that's given to us is that we're told that the angle is in the second quadrant. X is between pi/2 and pi. And so that means that we have to draw a triangle in the correct location to make sure that we can figure out what the cosine of x is and what the tangent of x is in order for us to get the correct positive and negative signs of those ratios to use them in the formulas that we see up above. So since our angle is in the second quadrant, so we're going to draw a triangle that's in the second quadrant. So here is our angle x. We use this reference angle in this location to figure out what the sine, cosine, and tangent ratios are. So the sine of x we're told is 3/5, so sine is opposite over hypotenuse. So hopefully we recognize this as being a 3, 4, 5 triangle, which means the bottom side of our triangle is going to be -4, since we're going in the negative direction for x. And so that means that the cosine of x for this particular angle is going to be adjacent over hypotenuse, so -4/5. And then tangent of x is going to be opposite over adjacent, which is going to be -3/4. So those are going to be the cosine and sine of our angle that we're going to use as we plug into the above formulas. So once we've got that, we can go ahead and evaluate what the sine, cosine, and tangent of the double angle is, of 2x is. So sine of 2x, we're just going to use this formula right here, is equal to 2 times the sine of x. Well, that was given to us. That's our information right here, 3/5, times the cosine of x, which we just identified right here, is -4/5. And so if we just multiply, we've got 2 over 1 times 3/5 times -4/5. There's no cross canceling or reducing that we can do. So we can see that the sine of 2x is going to be 2 times 3 times 4 on the top, so 24. 5 times 5 on the bottom, 25. And we've got that single negative there. So our answer is -24/25. In the case of cosine of 2x, we could use any one of those 3 versions of that formula. So if we just stick with the top one, we can say cosine of 2x is going to be equal to the cosine squared x. So that's going to be negative 4/5 squared minus sine squared of theta. So again, we were given that information, so it's going to be 3/5 squared. So if we work through that, we've got negative times negative is a positive. 4/5 times 4/5 is going to be 16/25 minus, same thing on the other one, 3/5 times 3/5, we're going to get 9/25. And so then that means that the cosine of 2x is, subtract the tops, 7/25. And we would have gotten that same answer if we had used either of the other two variations of the cosine double angle formula. And then lastly, we've got the tangent of the double angle that we have to find. Now, the identity for the tangent double angle is a little bit burdensome because we've got that fraction component to it. So 2 times the tangent of theta, we'd have 2 times negative 3/4 in the top. We'd have 1 minus negative 3/4 squared on the bottom. So there's a lot to have to keep track of. It's perhaps a little bit easier for us if we take advantage of our quotient identity from our original set of identities that we looked at the beginning of the unit that says that tangent of 2x could be rewritten as sine of 2x over the cosine of 2x. So as long as that angle is the same everywhere, that sine over cosine idea for tangent still holds. And so that means that I can use the two answers that I've already generated to end up with our answer for the tangent of 2x. So if I do that here, I can do sine of 2x, we found was negative 24/25, divided by the cosine of 2x, which is 7/25. Now that might seem bad as well, but if we recall, we've worked with these types of complex fractions before, so really what we have here is just a division of the top fraction by the bottom fraction. Or we could rewrite this as negative 24/25 times the reciprocal of that bottom fraction, which is 25/7. And so that means that we can do a little cross-canceling reducing here. The 25's go, and so we end up with tangent of 2x equal to negative 24/7. So instead of having to use the formula for the tangent of the double angle, we could just take advantage of that quotient identity and the work that we've already done, and then just go ahead and divide those two fractions or multiply by the reciprocal of the bottom fraction to end up with our answer.